So I was discussing about the multi-group analysis, that if you have a moderator which is binary in terms of coding, such like your gender variable, and you would like to see its moderating impact in whole of your model. If the moderating impact of your binary variable is on one relationship, you can simply use the same moderation technique which I have used in case of TS. But if you would like to see the impact of the moderating impact of gender in whole of your model, you can do it by you can say the multi-group analysis. So how can we perform the multi-group analysis? There is a simple way. You need to go to the back, and you need to go you need to click on your data set. Here there is an option of add group over here. You can simply click add group, and first you need to choose which one variable you would like to see as a multi-group analysis, and we would like to see the gender as a multi-group analysis, and it should be equal to value of 1 for male, and I would like to apply it. And yes, it has created uh, 1 for the male. Then I can again add group, gender is equal to 0 for female. This is how I have coded my data. So simply I applied it, and you can say uh, two groups has been created, 0 for female and 1 for male. And there are basically 110 female in my data set, and there are 254 male in my data set. So two groups have been created. So uh, after doing this, what you need to do, you go to your measurement model. Just like this, I have created this measurement model. Then I need to go to the calculate button, and there is an option of bootstrap multi-group analysis. You just need to click this, and here two groups are, you can see group A and group B. From group A, I have selected male, and from group B, I have selected female. Just you just need to select start calculation, and it will calculate your multi-group analysis, and it will show you the results of male and female case of uh, your model. In your complete model, it will show you how your complete model will be different for male and females. So you need to see these results. Just wait couple of seconds and you will see the results, how the male and female results will show here. Just wait for a couple of seconds more. So that's it. I think there are more things to come in results, and it will show you. Sometimes it takes time. If the model is too much complex, in our case there are two independent variable and one dependent variable, and one basically moderator TS we have used. But in many cases, when the model is too much complex, a lot of independent variable and a lot of moderator also, then we can see a lot of time required for analysis of multi-group analysis. So in case of simple model, such like in case of one independent variable and one dependent variable, the moderation of your multi-group analysis and the calculation of your multi-group analysis will be simple. So it is assembling the output, and you will see the results. So it has shown you, you can see in your picture, there is a button of female and male that you can see. So following is the result, that if you have collected data only from female, so what is your results? You can see here TS and R square is 0.517. Inner model is showing the path coefficient, outer model is showing the outer weights and loading, and you can see here your results. Like if I would like to see the path coefficient in case of female, you can see the difference in male and female and whether this difference is significant or not. And you can see here in case of the impact of PA on EI, that is perceived attitude on EI, which is basically the entrepreneurship intention. Here is the difference is positive, and that difference is weakly significant. In case of PB on EI, that difference is negative and it is statistically significant. Then in case of TS on EI, the difference is positive and statistically significant. Then in case of first moderating impact, the difference is positive and statistically significant. Then in case of second moderating impact, the difference is negative and statistically significant. So what does the difference means? The difference means if I have estimated some coefficient value for male and I have subtract the coefficient value of female from the male, I will find out these values. So if the difference is positive, it means that the coefficient value of the male would be higher than female. But the if difference is negative, it means the coefficient value of female is higher than male. So you can see here the differences. In case of first, we can assume that the coefficient value of male would be higher in case of perceived attitude on entrepreneurship intention, and that is weakly significant. Then in case of perceived behavior on entrepreneurship intention, the coefficient value for female would be higher. That's why it is negative. Then in case of TS on EI, the coefficient value of male would be higher. And in the same way, the first moderation impact for male is higher. So you can find here the value. Then you can see the bootstrap MGF. These are the same values that we have previously seen. Then the value basically which you should show in your publication is either you can show the bootstrap MGA, that is basically showing the moderating impact of male and female. You can skip the one tail male female p value. You should use the difference column and you should use the two tail p value column. And what next thing you can see here, the bootstrap result. These are the coefficient value for female, these are the coefficient value for male, and you can skip the uh, mean male and female values and standard deviation. We can copy to Excel like this. We can put it over here, for example, just like here. I can open it, and what you need to report in your publication results are, first of all, you need to delete these columns so that we can find out what are the values for the male and female separately. So you can see here the t value, the p value, and the coefficient values for male and female. You can see here for female, if I can highlight it, for example, this is for female. I can highlight in simple blue color. You can see here the t value of female. Then you can see here the p value of female. So if I would like to interpret the values from here, in case of female, there is a negative impact which is weakly significant, and you can see here the p value of the female. So there is a negative impact of perceived attitude on entrepreneurship intention. for the female, and the p value is, you can see the p value is weak. But in case of male, there is a positive impact which is not significant, because t value is less than 1.96 and p value is also greater than 40%, and should be less than 10%. So in case of female, perceived attitude is negatively impacting. In case of perceived behavior, you can see here, the females are showing a positive impact of perceived behavior on entrepreneurship intention, and your t value is greater than 1.96 and your p value is less than 0.05. So this impact is significant for females. But in case of male, this is negative impact, and it is weakly significant. You can see here the t value, and you can see here the p value for male. In the same way, if we want to see the moderating impact of TS, that is TS is basically tourism sustainability. So in case of a moderating impact of TS, females are negatively and significantly impacting, while in case of male, they are negatively impacting, but they are not significantly impacting. In case of TS on perceived behavior, uh, the the coefficient value indicates for the female there is a positive moderating impact, and it is highly significant, but in case of male, it is not significant. So this is how you can use the multi-group analysis, and this is the table which you should show in your article, in your publication. And the another one that you would like to show is multi-group analysis, this table. And how we interpret this table, just I need to show you here, like in next page. Just need to copy again, copy to Excel. Here you need to delete the one tail results, you need to consider the difference. So how can we interpret these results? Basically, it is showing that there is a difference of these impacts between male and female, and that difference is significant or not. So here we can see that in case of perceived attitude impact on entrepreneurship intention, there is a positive difference between male and female, and that positive difference is weakly significant. Then in case of perceived behavior impact on EI, there is a negative difference between male and female, and that negative difference is statistically significant. Then in case of TS impact on EI, there is a positive difference between male and female, and that positive difference is statistically significant. Then in case of moderating impact of TS along with PA on EI, there is a positive difference between male and female, and that positive difference is statistically significant. Then in case of TS along with PB on EI, there is a negative difference between male and female, and that negative difference is statistically significant. So in case of multi-group analysis, this table and this table should be placed in your article for the purpose of analysis. Preferably, you should use this table. It is called the multi-group analysis table, and this table is just for the convenience of your concept and convenience of your conceptual understanding, that why we should use this table. So this is how multi-group analysis is done. Now, how to resolve if you found an issue in convergent validity and reliability, discriminant validity and reliability, and how to discuss the common method biasness, R square, F square, Q square. So let me show you some other things. Go to graphical interpret, and we shall go back, and we should consider our basic model. which is measurement model, and for the purpose of measurement model we don't need to consider the moderating impact, because in case of measurement model we need to show their constructs. So they are indicators actually. So we need to show the indicators of this variable, then we need to show the indicators of this variable too, and then we need to show the indicators of this variable. I can consider it here like this. So I go to calculate PLS algorithm, start calculation, and it will show me some results. Then first of all, I need to see the outer loading. This is not an issue. E14 is not an issue, although it is showing in red color, but it is actually equal to the minimum guideline provided by here at all. Uh, as per here at all, the outer loading should be equal to or greater than 0.70. So as per the guideline, it is actually as per the guideline, or as per the cutoff criteria. So we don't need to worry about it. Next thing we need to see is the construct reliability and validity. If you see here, there is no issue over here because all values are showing as a green color. So we can say we could not find any issue in conversion validity and reliability, because these values are basically considered as a conversion validity and reliability. If they are shown in red color, there might be some error or some issue in your indicators. Then we need to see the discriminant validity. Here you can find here there is an issue of PB, TS and PB over here, because these values are greater than 0.90. Then if we see the Fornell Lorca criteria, here in first column there is no issue we have found here, but in second column there are issues we can find over here, because the second and third value of the second column are greater than the first value. You can also see in the third column the value is greater than from the first value. Then in case of cross loading, we may also find the similar issues in our variable. Like if you can see the TS1 to TS6, it is not only showing the higher values in its own construct, but they are also showing the higher values in other constructs too. Like in, if we can see the PB1 to PB8, they are not only showing the higher values in their own construct, but they are also showing higher value in other constructs too. So there are some issues that are basically related with convergent validity. So how to resolve this issue? The one method is to increase your sample size. If it is possible for you, then please increase your sample size. The second method is to see whether there is an issue in your indicators or not. You can open the outer loading. If you find some indicators are showing the values less than 0.70, it means you need to delete those indicators. But in our case, the indicators are good. So what we need to see, we can see the collinearity statistic. In case of collinearity statistics, at first you can see the collinearity statistic list wise. If in case of list the values are less than 5, it means there is no issue of collinearity. So here we can consider our collinearity statistic is good. But in case of inner model matrix, if you can see here, there you can find some issue in case of inner model VIF statistic. These values are showing greater than 3.3. This is basically a criteria which I would like to show you. Like here, I have collected some references for just a minute. I think this one. I need to open this. There is a guideline regarding the common method biases. This is robustness. Another one was maybe this one. I need to see the content. There is a complete book on it. There are some points which we need to consider over here. Yes, common method biases. This is basically an article which is referred to common method biases. So in case if your model shows inner structure with the value greater than 3.3, you can refer the criteria from this paper, and might be they have shown over here the criteria. I will highlight the criteria, but they have mentioned in somewhere that you need to use the value. Basically, if the inner VIF is greater than 3.3, you need to remove this, or you need to remove them, or you need to consider repeating those variable, like you can see over here, assessing conversion validity. In our case, the cross loading are showing more than those criterias, and there are some other. Yes, this is the common method biases criteria. You can see here they have highlighted one value which is greater than 3.3. So if your values of inner VIF are less than 3.3, they are good value, but if they are greater than 3.3, it means yes, this is where I would like to show you. As we can see, the model contaminated with common method biases include a latent variable with VIF greater than 3.3. So this was the criteria. We have also covered the issue of common method biases over here, because we have found some issues in discriminant validity due to common method biases. So what is common method biases, and how can we control it, and how can we adjusted in case if we didn't find any issue in construct reliability and validity, but we find some issue in discriminant validity? How can we consider, and how can we remove these issues? One simple way is you need to check if your statements are complex. Common method biases appears when the respondent didn't understand the question that you have provided in your questionnaire or in your survey, and they have without understanding that questionnaire, they have provided the same responses over and over again. If you collect data from a single responses in different point in time, at first time they have given you some response, and the in the other time they have provided you some other response for the same question. It means there is a common biasness in those responses. If you ask something from me, I give you some answer, and if you ask the same question from me in some other point in time, and I am giving you some other answer, it means there is a common method biasness in my answers. So it means that you need to verify your statement of your questionnaire, whether you have provided some statement which are complicated to understand for the respondent. So in case if it has appeared, you need to consider revising your data set. Maybe there are some entries error, maybe there are some you can say there may be some missing values over here, there may be some outlier over there. So you need to consider those values in order to control these issues. So these are the ways you can consider the common method biases. You can control the common method biases. The other method also involves uh, you need to see if I can show you the data set here. The issue is between PA1 to PA6, PB1 to PB7, and TS1 to TS6. So you need to check is in your data. You need to check, you need to revise your data set, or you can also consider you can also consider to increase your data set if you want to remove the common method biases. So in this case, there is a common method biases involved in this data set. So here how we can adjust these issues. Then R square, F square, and Q square, these are basically you can say the model explanation, or they are considered for explaining your model. So how can we compute these values? When we have run our model, we can see here the R square. You can see here the R square of your EI, which is dependent variable. It is 0.411. So here you can find the R square. Then the F square you can find over here. It is indicating that it is not good for PA, PB, and TS, because there are some problem in these three constructs. So you need to resolve the issue, and it would require some time to resolve this issue. So in case of Q square is basically the predictive relevance. How can you find the Q square? You need to go to the calculate, you need to go to PLS predict. This is an option which is used for Q square. Q square basically indicate that how much your model is good for predictive relevance. So here it is written, the PLS predict algorithm has been developed by Shimuli et al. 2016-19. The method uses training and holdout samples to generate and evaluate predictions from PLS path model estimation. The result also include the outcome of the cross-validative predictive ability test. So this basically indicates the predictive ability of the test. You just need to run it, and it shows that singular matrix is involved. So how can we consider? We need to base data set. We need to include them. No, it is again showing the singular metric issue. So we need to consider path model. Yes, it is showing again and again. We need to simplify the model. Let's see for this. There is an issue in the data. We need to use another data set for this purpose. We can consider another data set. For example, we can delete this data set and we can consider another data set. For example, this one. This is a data set from one of my paper. I would like to show you the raw data set from here. Yes, this one. All right. I need to recreate the model. So first you need to see how this data set basically is going to help us. This is the paper which is basically under review in some journal, and I would like to show you the basic model. This is the model I have run here, DIC. Basically, it is a higher construct, and I have arranged this data set for today's discussion. But first of all, I would like to run a simple model where MKTI, ORGI, PRDI, and PROI is impacting the BNKP. So I would run a simple model over here. MP and IP are my independent variable, like this MP1. This is my dependent variable, and I would like to run one independent variable from my basic model MKTI, let's suppose MKTI, this one, as a independent variable. All right. I would like to connect this one with this, and I would go to PLS predict, and yes, this is working, and you can see uh, it has basically done the procedure. You can see Q predict. This is basically the prediction power. The basic criteria of Q scare is basically if these values are greater than 0, it means your predictive relevance is good. So it is showing that MP4 is not a good predictor, while all other indicators are good predictor. You can see over here the more results, but the first one is very good, and here is the whole indicator predictive power, and it is also very good. So you can see here that MP is a good predictor. So in a graphical output, you can say that you can predict MP using MKTI, and it is a good predictor. So Q scare basically shows your predictive power, while F scare shows whether your model is statistically fit or not. So I have shown you some issues in the previous model, but if I would like to consider the present model and I calculate the PLS algorithm, and I would like to see whether this model having an issue or not. Let's see constructs reliability and validity, it is good. Let's see discriminant validity, it is also good. Fornell-Larker criteria, they are good too because these values are under the range. You can also see the cross loading. MKTI is showing significance value in its own constructs, while MP is showing significance value in its own construct. So there is no issue of discriminant or other validity. If you would like to see the VIF, it is less than 5, and if you would like to see the inner model list, it is also less than 3.3. So there is no issue of neither there is an issue of common method biases, there is no issue of discriminant validity, conversion validity. You can also run the multi-group analysis over here, and F scare, R scare are also very good. So this is how you can do a lot of things over here. What does mean by linearity? Linearity means there is a linear relationship between dependent and independent variables. So you can find the linearity when you run the model, basically through the bootstrapping. So if I go to the bootstrapping like this, bias corrected error, two tail, yes, these one. Yes, you can see here there are a lot of options over here. Like you can see the histogram, path coefficient histogram, indirect effect, total effect histogram, and outer weight histogram. Basically, linearity is assessed when your model is showing an impact, whether positive or negative. So in this case, there is a positive impact which is statistically significant. It indicates the linearity. You don't need to consider other criterias here. So endogeneity and heterogeneity we will discuss in some other day, because we have a lesser time to consider higher order constructs. So I think the majority of the things from here are clear to you. Let's start higher order constructs, because we need to consider the CBSM also after this. So let's start higher order constructs. The missing part, like endogeneity and heterogeneity, I will upload some recorded video in my channel, and you will see those videos how to consider linearity, endogeneity, and heterogeneity, because it will require some time, and I want to consider the higher order constructs here. So what does it mean by higher order constructs? And there are four types of higher order constructs here. So I would like to show you some reference material over here. Yes, this one. This is a paper which was published in Australian Marketing Journal, How to Specify, Estimate and Validate Higher Order Constructs in PLSM. You should read it because it is written by the premier author of Smart PLS, which is here at all. And it is a very good paper in order to understand the higher order constructs. They have stated that there are four types of higher order constructs, and you need to understand these basic diagrams in order to apply in your analysis. And I will use one of them in my analysis here using the same data set. The type 1 is reflective reflective. It means when you create some constructs like LOC1, LOC2, LOC3, and you have your indicators in a reflective mode. I have shown you the reflective and formative model constructs, and you believe